Have you ever entered a room and thought, what was I doing here? Okay, then you had a problem in a brain function called working memory. Working memory is the type of tool that our brain uses in order to retain information for very short periods of time, such as, for example, when you are going to a room and you have to remember the number, or when someone is dictating a text and you are writing it down. A lot of mental diseases have problems in working memory. A lot of really common ones, like Alzheimer's and Parkinson's, but also less common ones, like the one I'm interested, autoimmune encephalitis. In autoimmune encephalitis, what happens is that the body of the patient starts attacking their brains, and that is causing a blockage of communication between the neurons, between the cells of our brain. My aim is to try to understand how is the brain able to hold information, how is the network connected, and what happens when we have errors or when we have a disease, such as the autoimmune encephalitis. You might wonder, how are you doing that? Well, I'm using animals, I'm training mice in order to perform working memory tasks. Tasks where they have to use some stimulus and retain information. Depending on how well they remember, they receive more or less reward. Impressive, right? Okay, so this is only one part. The second part is that also, while they are doing that, while they are remembering, we are able to measure the activity of their brains. We can see exactly what's happening on their neurons. Using a technique called calcium imaging. This is really simple. Basically, looking at the surface, we see bright areas, and depending on how bright the areas, more involved in retaining the information. And if it's really dark, that means that that area is not responsible. If I succeed to combine these behavior tasks with the calcium imaging plus computational analysis, I'll be able to identify a lot of patterns needed in order to retain different kinds of information or working memory. By identifying the complicated patterns that neurons have to form in order to retain information, I'll be able to compare them then to diseased animals and spot the difference between what happens when you are able to remember something, but most importantly, what is happening in our brains when we forget.